Good morning, everyone. My name is Michael Maugeri. Welcome to my thesis presentation. My thesis is entitled ManaLens, and it is an image recognition-based management system for trading card games. And my advisor is Dr. Bishop. So just a quick recap overview of the reason behind the project. So I'd like to talk about the actual game, so Magic the Gathering. Magic the Gathering is a trading card game. It's one of the oldest, that's not true. It's one of the biggest it's one of the biggest trading card games to date. It started back in the 90s, so around 99, I think, 98. And it's been going strong ever since. The game consists of Magic cards. So you collect these cards, you build decks with them, and then you play people, and you try to beat the other person. One of the biggest issues with Magic the Gathering and players who play it is organization. As you see, I've got a binder here. So a binder can hold around like 250 cards, but most people tend to just throw cards like in a box, and then they're just under their bed, and they got thousands of cards in a box, and going through them is a nightmare because you got to just thumb through all these cards looking for like a specific card if you have one. And normally, or at least I do, if I can't find a card or I don't want to look for a card, I'll just buy a new copy. And then that only magnifies the problem. So I was looking for a way to sort of alleviate this. Also, trading. Trading is one of the biggest portions of Magic the Gathering. A lot of players don't even play the game, they just trade. The aftermarket is ridiculous, and you would be surprised at the price some of the cards can go for when you try to resell them to other players. All right, so that brings us to ManaLens. What is it? So as I was saying, it's a trading card management system. And the reason I wanted to do this project was ease of use. So there's a lot of tools online that you could use that would let you organize your collection, but they all have to do with typing in card names. All right? So I mean, just think, if I wanted to type in all the cards in this binder, that would take me a ridiculous amount of time. And this is like 1/10 of my collection. I've got a lot of cards, So it would be ridiculously time consuming. So I wanted a system where I could use a webcam to sort of take a photo or a video of the card and then be able to be like, oh, add this card to my collection, add this card. So that was sort of the reason behind what I wanted to do. And then I also wanted a system where I could manage the cards, so I'll be able to query and see if I have a certain card, or if I have a certain card, or I could sort by certain colors. So cards tend to have different colors, like this one's white, this one's green. So I might want to be like, oh, where are all my green cards, And I want to look through and be able to see what they are, or my white cards or red cards, And then I was hoping to make those profiles public so that you would be able to, type in the username of someone else, and you could look at their collection, and you would be able to sort through it and send them like a trade offer. Because the way right now trading works is you would have to go to a brick and mortar store. You would sit there with your trade binder, and you'd start asking people like, hey, do you have anything to trade? Hey, do you have anything to trade? And if people do, they'd pick up your binder, and then you would have to just sort through and see if there's something you want. It's time consuming, as opposed to going to someone's profile and just saying like, oh, I wonder if they have this card, and you could just search the card. So a short little story before we begin. So what is pictured here is the TCG Player application. So the day I handed in my thesis proposal, TCG Player, which is the largest Magic online retailer currently, they put out an app that basically does what I wanted. And I was furious. I was so angry. I wanted to call them up. I wanted to sue them. But I mean, they probably had this in development for a while now. And as you can see, you scan a card, it adds it, it's got prices, and then you could go through your collection. And I was lucky enough to talk to the lead developer of this application. I managed to connect with him on LinkedIn, and I just sort of pestered him until he gave me a phone call. And I just sort of picked his brain about the process he went through and sort of how. And it really gave me a nice head start as to where to sort of take the project.
Are those real prices there?
Yeah, those are real prices.
And do you have to send it by mail then, or how do you share it if somebody buys it?
Yeah, so for their platform, you can either upload it to your account, and then you could sell it through their thing, but you need to do all the shipping. But they handle all the, prices and selling and everything. But yeah, you would need to ship it out to the person.
Makes sense.
Yeah.
So this developer, is he associated with the game somehow, or is he just a third party?
No, just a third party. So Wizards of the Coast, which is the company that makes this game, they've never really put much money into this stuff. They actually are not allowed to acknowledge the aftermarket. It's against their rules of acknowledging prices for cards. So this is all without their knowledge. Knowledge. They know.
There is a central authority or whatever for the game.
Yeah, there is a central person for the game. He was not affiliated with that. So the tools I used, mainly I use Java. It's what I know. It's what I like. I've got Python there solely because the library, JavaFX, OpenCV, which I used, the documentation for Java is almost non-existent. If you go to the API, it has the method names and that's it. No descriptions, nothing about it. But the Python API is glorious. I mean, it's got everything you could ever want in it. So I sort of had to learn how to do it in Python and then translate it to Java. It was kind of a nightmare. But I thought I'd just mention that. JavaFX, which is a GUI program. OpenCV, which I used for a bunch of the image recognition stuff. MariaDB, which I used for the back end. Scryfall, which is the largest online magic database, which I use to get card images from. And then the TCG Player app, or API, which I used for prices. So I'll go into detail about them now. So for JavaFX, like I was saying, it is a UI program. And I really liked it because you would be able to drag sort of a pop-up. And then on the pop-up, you could just drag and drop a button, a button here, a slider. And you could just drag these elements onto the pop-up. And then you have to code the back end for it, but it's very nice. It's just drag and drop. I didn't want anything too complicated because this wasn't the focus of the project. So I thought I'd just mention that. Next, OpenCV. So OpenCV is a fantastic image processing library. It has stuff like smoothing for images, object detection, and it also has sort of a bunch of stuff for machine learning. I dabbled with machine learning for the project, but I realized quickly that it wasn't going to work because machine learning would be able to tell you that the thing in the photo is a magic card, but it couldn't tell you what it was, what the magic card is. So I quickly scrapped that idea. It allowed me to capture webcam video and then be able to find the card within the camera, within the photo, which was very important because otherwise, how would you know? I didn't want it to be you had to zoom in perfectly where the picture was just the card. I wanted to be able to, you could do it up here and then it would just crop it for you. And then it had some bitwise arithmetic stuff, which is useful later, as I'll get into. For the back end, I used MariaDB. So I chose this over Postgres because it had some functions that I needed. For some reason, Postgres didn't have these functions. I'm not really sure why. Specifically the bit count, which was invaluable to the later parts of the project.
Is MariaDB a version of MySQL?
Yeah, it's what the servers, one of the servers upstairs is running it. Next, I used Scryfall API. So as I was saying, this is a magic database, and I used this database to sort of populate my database with the information. So I wrote a script to sort of rip all the images off there, put them into my database, and then be able to cross-reference a card coming in being scanned by the user against the cards in the database to see if they're the same or not. And then the TCG Player API. So I wanted to get prices working for this demo. I started this like a week ago. I just had some free time. I wanted to do it. But I'm waiting on an API key, so I wasn't able to get it working for this demo, unfortunately. So the code's there. It's just not working.
So the idea here is that you were going to take the current prices from that app and populate it into your...
Yeah, so TCG Player has they aggregate prices of like what the card is selling for and give you like an average. So these are all the average prices of these cards specifically. And so you can query into their API and return like the current mid price for the card.
What's that based on? Price.
What they're selling for. So every time a card is sold, it remembers the price, and then that price all the prices that the card was sold at are used to...
How does it know what prices are sold for?
Well, it's a Magic Online retailer. They retail Magic cards.
Oh, so they're the ones doing people are buying and selling through them?
Yes, exactly.
Are there any other venues for buying and selling?
Oh yeah, there's a ton. That's just the biggest one.
So the prices of these cards, I mean, they change like every day, right?
Yes.
It's crazy. It's like a stock market or something.
Yeah. I'll show you later. There's some crazy examples.
So would you just constantly be updating it?
Well, the thing is, I would only get the price when you're scanning it. The point is to scan a card and then get the price as you scan it.
Okay.
And that's the price you use for like the moment. It's not going to change within like 10 seconds,
Okay.
So if you're trying to trade with someone, you both scan your cards, you try to get an even price so that nobody's getting ripped off, and then you make the trade,
Okay.
So to go through the process of how it works, I start with canny edge detection, which is how I actually find the card within the picture. I create the bit string using the algorithm for turning the photo into an actual thing. Color channels, I'll get into that in the next slide. I populate the database, and then we've got to check the database against the card coming in and the populated database to see if there's a match. And then we check the Hamming distance to actually do the matching. And then finally, we report the results back to the user to see if we have a match or not. So just to start off, we're going to do a little quick demo for the edge detection. So we're going to go here, set it to 25. We're going to start the camera.
What are you running?
I'll show you. I'm running the program, which is just going to demonstrate one concept really quickly. Okay. Oh, wow, that's abysmal on there. All right. Well, it looks nice on my laptop. If you can see, just barely, everything about the card is black except all the edges. So, I mean, feel free to come up. Yeah, it looks nice on my computer. But as you can see, all the edges are this white line, okay? And that's very important because what canny edge detection does is it finds the contours of an image. So one important thing about the system is you have to scan using a white background. And what it does is it finds the transition between the white background and the black border of the card, and that counts as a contour. And so it scans the image, it finds all the contours, and draws them out for you using a white line. And then what you can do is request that white line in the form of a vector. And they have some cool functions that let you just get the outside line, which is very important because you don't want to crop just like the text box because that's not the whole card, right? You want the whole card. So it takes the outermost border, puts it into a vector, and then reports it back. And then once you have that vector, you're allowed to crop the image at the point where just the card is.
So you do like an axis aligned crop?
Yeah.
Like, so if you rotated the image, you've got like the boundary dots around that.
Yes. You'll see as as we get further into the demo, you'll see how it works. Oh, a set that's not showing. Whatever. So once we have the cropped image, we're going to create the bit string. All right? So this is a very helpful, sort of simplified process of how we do the algorithm. So we take our source image, which in this case is the cropped image we just got from the edge detection. We're going to grayscale the image. We're going to reduce it to an arbitrarily small size. The convention is 8 by 8, just to sort of reduce everything. And then we're going to actually create the bit string. So this algorithm being depicted is difference hash. So what that means is it's going to take the pixel and compare it against its neighbor. And depending on if it's lighter or darker than its neighbor, we're either going to get a 1 or a 0 when we're creating the bit string. And so what we do is we go through, comparing against each pixel, and we create this bit string, which is going to look like this. Just a bunch of 1s and 0s. And this is our digital representation of the image. Okay? One thing I want to point out is I decided to go with difference hash. It's sort of a middle-of-the-road hashing algorithm for images. It ran the quickest, I felt, and it gave me the most decent results in comparison to time. I implemented a couple other ones, but I really like this one the best.
So what you just described, in other words, the way it comes up with the bit string is by comparing each thing with the one to its right or whatever.
Yeah.
And that's called what?
So,
Hash something?
yeah, these are all called hashing algorithms. I know I've gotten flack in the past for calling them hashing algorithms, but that's what the convention is. They're called hashing algorithms for images.
Okay.
I know they're not being hashed into any sort of, data structure, but that's just what they're called.
But it seems to me, though, that is collision a problem? I mean, how many images would hash to that representation, that particular representation?
I'm not sorry. I'm sure I'm not
Well,
understanding.
you're losing a lot of information because you're compressing it down to,
Yeah.
So why wouldn't you have a lot of collisions? I mean, multiple cards having ending with the same bit string representation.
Well, you would, and that's why I want to talk about color channels. Okay, so with the way this worked is because we went to grayscale. Okay, we lose a lot of the specific differences that make up an image. A red card should not be the same as a green card, right? The color matters. And so because we were just grayscaling and then doing the hashing, it was giving me very not accurate results. I was getting a lot of overlap, cards matching with each other. And that's not ideal, right? We don't want that for the system. So what I want to point out here is, let's say we have an image that's 3 bars of color, okay? Solid green, solid red, solid blue. If we were to just grayscale that, we would get all, black, just one color, right? Because these are all the same intensity, and it doesn't matter what color they are because we're just grayscaling it. We lose the specifics, So Dr. Bishop had proposed an idea of, okay, well, let me give you a couple examples. So these are 2 cards, okay? Both of these cards depict some form of, monster with a bunch of heads, coming from the left, going to the right, okay? If you'll notice, both cards have 3 circles up here, but this one's red, this one's green, these are both green, okay? And this card is yellow, right? It's got red trim over here. This card is green. And there's a couple things that look similar, right? We've got this orange little symbol in the corner. This text is identical. They both have pretty hefty text boxes. And my system was reading this, and because we were just grayscaling it, they were coming out as the same card, which in reality, that's not true. Not true at all. And one more example. This one will be quick. I thought this was a great example because it showed 2 faces sort of in the same pose. If you were to just grayscale it and then shrink it down to 8 by 8, my system was thinking it's the same thing. Oops. So color channels come into play because it lets us preserve those subtle details of the colors, which is very important. So what we do is we take the original image, we turn it into its color channels. So the basic colors in a computer are red, green, and blue. So when we split it up into the red color channel, all the red colors stay red, but everything else turns to a gray, okay? Same thing with green and blue, okay? But now once we have these, if we grayscale these, we get a level of a description that we didn't have before, right? Because now we can clearly see that there was, a red stripe here, or there was a green stripe here, or a blue stripe here. And this lets us sort of distinguish between colors, even though we're grayscaling it now. Does that make sense to everyone?
Mike, what's the original representation of the image? Do you have 3 bytes for each color, 1 byte for each color? When you got the image from the camera, okay, what's the representation of the image? Each pixel has 3 bytes. Each byte represents the intensity of the red, green, blue.
Yeah, I'm trying to remember. Yeah, it was, okay. I think, if I'm not mistaken, let's do it over here. It was 1 byte, so it was 2 things for the red, green, blue, and then there was an intensity channel, I think, if I'm remembering correctly.
Probably alpha.
Huh? Oh, the alpha channel, yeah. That's it.
Oh, okay.
Yeah, sorry.
So, yeah, each circle represents 4 bits, right? So 2 circles represent a byte there. So the first 2 represent the intensity of 1 color, either blue or red or green, right?
Yeah, yes. Yeah, sorry, I'm just struggling to remember. So once we have the color channels for each and we've grayscaled them, we carry out the hashing algorithm on each of these. And instead of having a 64-bit string, we now have a 192-bit string, which is 3 64 bits just concatenated together. And now this is our digital representation of the card, which we then store in the database. So as I was mentioning, I used Scryfall to fill the database. So with the help of Joe Ganal, if anybody remember, he helped me write a script that went to Scryfall and get all of the relevant information. So just a quick little demo here. This is how Scryfall looks. And if you were to search for, right now I'm searching for all the cards in standard. So standard is a subset of Magic the Gathering, which just means that all cards that were printed in the last 2 years. So I thought this would be a nice subset as a proof of concept, because at the moment I think there's like 15,000 cards in Magic's history, while in standard there's only 1,700. And so this was just easier to do like a small subset to make sure the system works. And what I want to point out is if we were to go to a card, we could download its JSON. All right, and so we would go through the JSON and find the PNG, which is the high-res image that you saw earlier. And so we go through here, we get all the links, we go to the links, download the image, I run it through the hashing algorithm, and then we put it in the database. So that's how we populated the database to be ready to check cards being scanned.
Did you use high-resolution images for your database?
Mm-hmm. Yeah, it's really not a big deal because they're going to get shrunk down to 8 by 8 anyway. But I thought it would just be better to start with high res and then, shrink down.
So this is a JSON file?
Yeah, this is just for that one card. And so...
So from this file, you just needed that one line that told you where the URL of the image?
I needed that, and then I needed, where is it? The name of the card here.
Oh, right.
So those were the 2 important things I needed from this file.
So Mike, you actually do not store the image in your MariaDB. You only store the link.
No. We store the bit string from hashing the image.
Okay.
We store the bit strings in the database.
Right. That's the kind of the representation of each card in your database.
Yes, exactly.
But do you keep a copy of the image in your database?
No, we've just got the name in the database also. Because, with the name, you could just figure out what card it is. You don't really need to see it.
Yeah, I ask you that is because if you get into a copyright.
Yeah, no, I had to worry about that. That's kind of an issue. Okay, and then just a quick shot of the database. So the database has the card name and then the bit strings independent, the red bit string, the green bit string, and the blue bit string. For some reason, MariaDB didn't allow me to create a bit data type longer than 64 bits. I don't know, I would have thought you would be able to, so I just had to settle for doing 3 specific bit strings for each color. And then once the database is populated and the user is scanning a card, we're going to take the card being scanned bit string and we're going to compare it to the database. And we're going to find out the Hamming distance. So the Hamming distance is what we figure out to see if a card is a match or not. So the Hamming distance is defined as sort of the difference between 2 bit strings. So here, this is a 1, that's a 0. That would add 1 to the Hamming distance. That's a 0, that's a 1. That would add 2 to the Hamming distance. And so in this example, we have a Hamming distance of 7. And what you want to shoot for is the lowest Hamming distance, because that means it has the greatest possibility of being a match. All right, so we're going to get started with the demo. Before I begin, I just have some numbers. So in my hands, I have 6 booster packs, okay? So a booster pack is a supplemental Magic the Gathering product. And each pack I have in my hand is from a different set. So a set is just sort of an expansion. Each set usually has around 250 to 300 cards. And currently there's, I think I said 1,700. This is a bit off because the new set just came out like yesterday. 1,500 cards in standard currently. So in these 6 packs, we could have any 15 of those 1,500 cards, okay? So I just want to point out this is completely random, okay? These are brand new packs. I have no hand in this. And this is a great way to test the system because it's completely random. I have no bias, right? I just open the pack and we're going to scan it, okay?
So you're doing this without a net, is that it?
Yeah, basically. And to even remove myself further, I would like one volunteer to come up and scan the cards. Anybody at all. You're going to pick a card.
Well, he has his hand up.
Yeah.
What, you want?
I don't
You
know
wanna?
if it's scanning.
Yeah, come on up. So I'm going to let you pick any pack, okay? Open it, take out a couple cards, and we'll scan them, okay?
How do I know you're using another pen?
Yeah, it's like a plant.
But would you guys like to? Oh, I'm open to anybody doing it. Anybody at all.
This is coming into a magic show.
Yeah, I know. I feel like a magician. Yeah. Yeah, let me just see it real quick. So one thing I want to do is there's a couple promotional cards in here that can't be scanned, specifically the last 2. So I'm just going to take those out.
Can't be scanned, what?
Because these aren't technically game cards. It's like promo stuff for the next set or like basic lands.
They're not cards of the game.
Yeah, they're not really cards. Yeah, you could, no, you could just scan that. That's fine. Yep. So we're going to go here.
But shouldn't you pick a card that's already in your database?
All of these are.
Oh, they are.
Because I added every card in standard,
Oh, I see.
and all these packs are from standard. All right, so no safety net. Let's go. Let me just describe how the system works, okay? So you're going to take the camera. You're going to hold it about elbow length above the table, and you're going to take the card you want to scan. We're going to put it there, and you just let it scan. I would suggest looking at the computer to sort of make sure it's in the frame, but I'll let you go.
Tom, before you do it, could you move the chair? Yeah, it's kind of just blocking.
I don't want to smash the camera. There you go. All right, so we're going to start the camera and give it a shot. So it's going to show up here what the system is seeing, and what you want to do is sort of get it within the frame.
Zooming in on itself, right?
Yeah, no, you got to turn the camera a little more the other way. Yeah, see, so you'll see Rosemane Centaur is showing up here, and that is the name of the card. So if you want to scan a couple more, feel free.
I
Also, if anybody would like to try it, feel free to come up. We can open up another pack, try that one. Yeah, so Demir Spybug, which is the name of the card. Yeah. One thing I want to mention real quick is you see this error here? That's not my doing at all. For some reason in the the jar file, there's a code that I can't edit, and it throws errors every time you don't pass it a card. I'm not really sure how to fix it. So what you could do is, here, watch. Oh, sorry, these cards don't work. These are foil cards. Those are busted.
That's because they're reflected.
Yeah.
Yeah, that probably doesn't help.
So let's try, I don't know, one or two more. So this one's called Hunted Witness. So if you'll see, it's getting at one or two false positives, but for the most part it says Hunted Witness. And then let's try Unexplained Disappearance, okay? So as you can see, Unexplained Disappearance is showing up. Does everybody see that?
Yeah.
So yeah, like I said, if anybody would like to try it, feel free, but I think that,
Well, there was a little loss of accuracy there. How would you explain that in that particular case?
sure. White's kind of a tough color for some reason, I've noticed, because to make white, I don't want to get this backwards. Does white have all the colors or none of the colors?
All the colors.
All the colors, okay. So you tend to get some sort of errors with white because the color channels don't work as accurately as they do with the other colors, like specifically, red, green, or blue,
And in terms of intensity, would be 0, right?
Zero
Why?
should be black.
Maybe 256, right?
No, it's
55.
I mean, in web design, FF is 256, and that's for white. FF, it's for white, and 0000 is for black.
Yeah, that's
Yeah,
correct.
but in web design. In physics, white is all the colors.
But yeah, when you specify the intensity of the three colors, red, blue, and green, I think that they are all 0, then it's white.
No, that's
Are you
backwards,
sure?
yeah.
Okay. I'll do that. I'll do that.
So, I mean, is everybody okay with that demo? Would anyone like to do more or anything? No? Okay. So I'll get back to the presentation.
What is the usual about the, I think, the magic
Penn and Teller?
Yeah, and the,
Oh.
something, about the.
Oh, fooled us?
You fooled us.
Yeah.
So you did.
Well, no, there's no fooling here. It's all truth.
The guy who talks, the guy who doesn't talk.
So to continue on for my findings and results, so when I tested this in my own home, I opened up 5 booster packs, and from